Hi, in this video you'll be seeing a few approaches on how you can run code when you are initializing a class or when you are initializing a Java application, a Java web application, or an EJB. So I have here a simple project using Maven. So it's a War project with a few dependencies on SLF4J, Java EE API, and JUnit. So the first one of the approaches you'll be seeing is how to use static initialization block. So let me create a class here called static block, and then in all the examples here we'll be using just a log message, just a few log messages to show what's going on. So let me initialize a logger here. We have the SL4J logger in the class path. So get an instance of the log, and then how you declare a static block. So a static block is declared by using the static keyword and then the curly brackets. So everything you place within this block will be executed when the class is first loaded by the class loader. So this is going to be executed only once for that class loader. So let me just print a message here. So static block, right? And then here I have one method that is static, and then we have a simple constructor just so that you can see when the static block is exactly executed. So let me create a test class here, static block test. Sorry. And then let me just get a logger here as well. Yep. And then I will have a test method called, for example, instantiate class. And then here you have a message here. So before invoking the class in the static method, so before invoking static method, then you have the static block dot some static method, then one more message before instantiating the class, and then let's create two instances of this class. So let's run the test here just to see the output of the messages, so you can understand what's going on here. So console, yep. Increase the window here. Okay. So I have here the first message invoking static method. This is the message, and then we invoke the some static method. You see that the message of some static method is here, but before this message you have the static block, right? So the point here is, at this point the static block class has not been initialized yet, has not been loaded yet. So at this point we need to invoke a static method, but before running the method, the class needs to be loaded by the class loader. And at this moment our static block is executed, and only then the static method is going to be executed. That's why we see first the message of the static block and then of the static method. And then you see the message for the constructors, but we don't see this message being executed any more time. So this is one way of executing a method when the class is first loaded. Okay, that's good. Let's see one more approach now, that is using the default initialization block. This is very similar to the constructor, but let's see the difference. So we have an initialization block class. Then we have here, I'm just grab here the logger. So we have a constructor, a default constructor, and a constructor that receives a message, and let's declare initialization block. It's very similar to the static block, but in this case you don't have the static keyword, you just have the curly brackets. And then let's add some message. Initialization block invoked. So this initialization block is going to be executed every time the class is instantiated. What's the difference between this and the constructor? If you copy this code here for here and here, it's exactly the same idea. This is what is going to happen in practice. The compiler is going to copy this before the execution for each constructor. So this code is going to be copied for every constructor. So it's a way for you to save some time, so you don't need to copy the code for all the constructor or manually invoke that code for all the constructors. So let me just create a test class here. Initialization block test. So I'm gonna run the constructor. I'm gonna invoke the constructor twice, different constructors, and you see that you have initialization block being invoked, and then the output of the default constructor, which means that the default constructor was invoked. Then you have again initialization block code, and then the code of the constructor. So it's a way for you to use the same code for all the constructors you have in your class. So you don't need to explicitly invoke that code. Okay, what you have seen here is for running code when your class is being loaded or being instantiated, but very often you also need to run code when you have a war application, and you need to run code when the application is started by the container. So let's see 3 different approaches of doing that. So the first one, we have an initializer listener. We'll be using a servlet context listener. So as you may know, the servlet API contains a lot of different servlets, different listeners that you can register for. So you can register a listener for when a session is created, you can for when a request is created, and you also can register a listener for when the application is initialized by the container. So I'm gonna just implement the servlet context listener here. Then we need to add the web listener annotation from the package javac servlet annotation. And then this interface here provides 2 methods, one context destroyed and one context initialized. So let me copy the logger initialization here. The context destroyed is invoked when the application is undeployed, and the context initialized is invoked when the application is deployed by the container. So let me just add here. Okay, so I have here, I'm gonna compile this application, and I have here a Wildfly server being executed. You can use any JE6 compliant server. So I'll just copy the application here, and you see that the listener was invoked by the container automatically. So this is one way of when you want to run some code at startup. There is one more way that the servlet specification helps you in doing that. That is using a peer servlet. So let me create initializer servlet. So we need to extend HTTP servlet. Let me just copy the logger here, and then for the servlet, when a servlet is deployed, the container just creates one instance of that servlet, and then all the requests that come to that servlet, the container will create new threads, but the instance of that servlet will be the same for all the requests. That's the life cycle of the servlet. And there is a method in the life cycle of the servlet specification that is invoked when the servlet is created by the first time and the only time. That is the init method. So I will just override the init method here and add a message here. So logger.info servlet created. Then we need to add the web servlet annotation to make this register the servlet in the container. But there is still one thing here to sort out. By default, a servlet is just initialized when it receives the first request, so it is just lazily initialized. But there is a way we need to force the servlet to be initialized as soon as the application is deployed. So we can use the loader on a startup parameter and give the value 1. So this will force the servlet to be created by the container as soon as the application is deployed. We don't need to wait until the first request comes. So let me just compile the application again. Copy it to the application server, and I will see that we have the listener being invoked, and we also have the servlet that is being invoked. There's a typo here. So this is one more way of running code when you are initializing your application. Let's see one more way now, that is using NJB. There is other typo here. Let me just fix this. Initialize servlet. Initializer listener sounds better now. So let me create an initializer JB. So when you define NJB can be a stateless, can be a stateful, or a singleton. When you have a singleton JB, it means that just one instance of that JB is going to be created. So that's what you want. You want just one JB to be created. Then let me add the log here, and then we'll have, for example, a method. You can give a name to it, init. So JB created, and the JB specification states that in the life cycle you can have a method called post construct that will be invoked as soon as the JB is created by the container. But again, by default the JB is just created when it's required, but there is, sorry, here I should be using the singleton JB, so I have spoiled what I was going to show you. We can use the startup annotation to force a singleton JB to be created as soon as the application is deployed. So again, by default an JB is just created when it's required, but if you want to force some code to be executed as soon as the application is initialized using JB, you can use the startup annotation, which will force your JB to be created as soon as the application is deployed. So let me just do the same process again. Let's see what happens now. We should see 3 messages now. So now our JB is being deployed, and now you see the message of the JB created, of the listener, and of the servlet. So I hope it was useful by somehow to you. There are different approaches that you can use to run the code when your application is being deployed, or when your class is being loaded or instantiated, and I hope you enjoyed it.